Hey, what's up, AP Calculus? In this video, we're going to learn a new derivative rule called the chain rule. And you're going to be using this rule when you try to find the derivative of a composition of functions. So let's just quickly review what a composition of functions is. So imagine we had a function f of x equals x squared and g of x equals 3x plus 2. And we want to define function y as f of g of x. So let's see what function y would come out to. So we have y equals f of g of x. So y would be f of 3x plus 2. So that means y would be parentheses 3x plus 2 gets plugged in the function function f, which just says to square the input. And we could leave it like that, or we could write it in expanded form. So that would be 9x squared plus 12x plus 4. Okay, so now I'm going to give you what's called the chain rule using prime notation. There's another notation, which we'll do in another time, which uses Leibniz's notation. But for now, we're just going to do it like this. So if you want to do the derivative of f of g of x with respect to x, you're going to write it as follows. F prime of g of x multiplied by g prime of x. So f prime of g of x times g prime of x. And we want to remember this rule and use it correctly, so in these next few examples, you'll kind of get the hang of it. All right, so let's take a look at problem number 1. Problem 1 says find the derivative without using the chain rule. So is there a way to find this guy's derivative without using the chain rule? Well, we could always write this in expanded form. If you notice, I'm just using this function from up here. And now that it's in expanded form, we could just differentiate one term at a time. So we could say y prime equals, using our power rule, 18x plus 12. And we could leave it like that, or we could write it in factored form, which would be y prime equals, we could take out a 6 and write 3x plus 2. Now, no big deal doing it this way, but you have to imagine if that exponent was a 7 and not a 2, well, writing that in expanded form would be a very challenging task. We'd have to use Pascal's triangle and it'd be super long, maybe not worth doing it that way. So that's where the chain rule comes to save us. So when we work out our derivatives with the chain rule, we're applying it because we're working with a composition of functions. So the outer function is the squaring function, and the inner function is 3x plus 2. So when we apply the chain rule, we want to write the derivative of the outer function, which is the squaring function, while leaving the inner function the way it is. So we're going to say y prime equals, now using my power rule, I'm going to take the 2 down to the front. I'm going to leave that inner function alone. I'm going to lower that exponent to 1. Now, to complete the chain rule, we're going to do this part where we multiply what we have here by the derivative of g of x, which is the inner function. So times the derivative of that red guy using our derivative rules would just be 3 plus 0. So we can multiply the 2 with the 3 at this point and leave our answer in this form. Or we could distribute it out and write it as 18x plus 12. Either form is correct. So you can see we got that same answer using the chain rule as we did doing it the old way. All right, now moving on to the next few examples, we're kind of stuck here. We will have to use the chain rule. So the first thing we're going to do with this guy is let's write it in exponent form. That would be a little more helpful. So don't call it f prime of x yet because we're just rewriting it. So 9 minus x to the 2/3. And now we'll just apply the chain rule to this one. So f prime of x would be doing the derivative of the outer function, which is something to the 2/3 power. We could use our power rule. So we'll get 2/3, leave the inner function alone. Subtract 1 from that exponent would give us -1/3. And then to finish the chain rule, you simply have to multiply what you have there by the derivative of the inner function, which is the red guy. So 9's derivative is 0, negative x has a derivative of -1. And then we'll just clean this up. So we could say f prime of x equals, multiply them together. We could leave it like that, or you could write it without the negative exponent. So it would be -2 for my numerator, 3 times 9 minus x to the 1/3 for my denominator. Okay, so when we go to the next one, we have two terms, so we're going to differentiate each term one at a time, but we are going to have to apply the chain rule to each one. So here's what I mean by that. Let me write this a little better. I could keep this as sine parentheses x squared. Now, when we have an exponential function, your inner function is actually the exponent. So it'd be helpful to put that 3x in parentheses so we can focus on it. All right, so now we're all set up for the chain rule. We're going to have g prime of x equals. In this case, my outer function is the sine function, so that would go to cosine. Leave the inner function alone, and then multiply that by the derivative of the inner function, which would just be 2x, plus. Now the funny thing about e to the x, e to the x's derivative is just itself. So when I do the derivative of the outer function, which is e, I'm just going to write it the way it is. But then to complete the chain rule, I do have to multiply by the derivative of the inner function. So we're just doing the derivative of 3x, which would be 3. All right, so when I clean that up, I could just say g prime of x equals, we'll take that 2x to the front, cosine of x squared plus 3e to the 3x, and you could leave it just like that. Okay, so on the back, we're just going to go over problems 5 and 6, and then I'll stop the video. So for number 5, I'm giving you a function where we could use the quotient rule to get its derivative. So why don't you pause the video, see if we could just get that one taken care of by just using the quotient rule. And then I'll do number 6 with you where I could show you how this could be done by applying the chain rule. All right, so just pause the video, do number 5 on your own, just see if you could get it. Okay, welcome back everybody. So hopefully you ended up with -10x over x squared plus 3 quantity squared. So I got low, d high would be 0 because 5's derivative is 0, minus high d low over low, and that cleans up to that. So when we do this same problem with the chain rule, we need to get the same exact answer. So how do I apply the chain rule? Well, I have to rewrite this without a fraction. So what that means is we'll just keep that 5 there, and we'll times it by x squared plus 3 to the -1. So now that it's in that form, I could apply my chain rule to it. Now I don't have to use the product rule because 5 is a constant, so I'm going to be using my constant multiple rule when I write it out. So we're going to get y prime equals, starting with my outer function, which is a power function, using my power rule, I'm going to take the -1 down, multiply it with the 5, keep the inner function the way it is, subtract 1 from that exponent, we'll get -2. And then to complete the chain rule, we're just going to multiply by the derivative of the inner function. So the derivative of that red guy is just going to be 2x. And now when I put that together, I will get -5 times 2x is -10x times x squared plus 3 to the -2. And if I write that without the negative exponent, it's just going to look like what we have from problem 5. So it really doesn't matter which way you do it. I don't know if one is any better than the other. You're just going to, over time, pick a way that works best for you. All right, I'm going to stop the video here, guys. Hopefully that made sense, and we'll do a few more of these together in class. Toodles.